Okay, we are back. We are looking at section 2.1 and 2.2 in our textbook, and specifically at normal strain. This is example 2 if you're following along with your PDFs. So we have a rigid steel bar that's supported by 3 rods. There is no strain in the rods before the load P is applied. After load P is applied, the normal strain in rod 2 is 1080 microinch per inch. Assume the initial rod length is 130 inches of 1, and of 2 it's 75. Determine the normal strains in rods 1 and the normal strain if there's a 1/32 inch gap in the connection between the rigid bar and rod 1 at joints A and C. Okay, so again, there's a lot going on. This is where you have to start keeping up with your information. So I have a rigid bar. That's important to know. It's not going to have any distortion in the bar. Like it's not going to bend like a rainbow as we pull down. It's going to come down um, as a unit. We also know that bar 1 and 1 on the outside are the same. And bar 2 is symmetrically in the middle. So I know that the whole thing is going to come straight down. Like the whole thing is going to come straight down. So if we can find the delta, the change in length of L2, that's going to also be the delta of L1. So because it is symmetric and we have a rigid bar, then I can say that delta of bar 1 has to equal delta of bar 2. Okay, so there is no strain before we get started. That's good to know. After load P is applied, we will end up with a strain in rod 2. So we have a strain here of 1080, and I don't know why I put the micro strain in front of it because that is not our unit. It's this equals 1080, and that's a micro inch per inch. Okay, so strain is our change in length over our original length. If the initial rod lengths are, so these are 130 inches, then, and this one is 75 inches, then I want to calculate the strain in rod 1. So again, I'm going to start with rod 2. And with rod 2, I know the strain. I know the original length. Okay, this is all I have in my equation. Known, I can calculate. Then, based on this, the strain of the deformation, the delta of 1 has to equal the delta of 2 because of symmetry, it's not going to rock like this or like that. Delta. Now we can look at rod 2. Strain equals change in length over length. I have that displacement, that delta. I have my original. I can go back and calculate the strain of rod 2. So, you know, again, in this class, we don't have a lot of equations, but you have to understand what you have and where you're headed. This is all we're working with right now. So let's look at rod 2, which is also B, whatever you want to call it. So strain equals change in length over length. So the strain of 2 equals the change in length of 2 over the original length of 2 equals 1080 times 10 to the negative 6th inch per inch, or sorry, I'm getting ahead of myself here. Let's back up. 1080 times 10 to the negative 6th inch per inch equals delta 2 divided by 75 inches. So delta 2 has to equal, sorry, I had a video just finish up over here. Okay, delta 2 has to equal 0.081 inches. We had a positive strain. So positive strain means positive change in length. So it's getting longer. So this is longer and not shorter. Okay, now I can go back to rod 1, which is A and C, and strain of 1 has to equal delta 1 over length of 1. And we have delta 1 equals delta 2. So our strain of 1 equals 0.081 inch per inch divided by 130 inches. So our strain of 1 is 0.000623 inch per inch, which in microstrains 1, 2, 3, 4, 5, 6, 623 micro inch per inch. So there we have it. So that's the strain. Now it says, what if we have a gap in our connection? Okay, so maybe this gap came from a bearing stress, kind of like failure, if you want to call it that, where we created a gap in here, or maybe we have it built in so that we have some like wiggle room in the system. So what happens if we have a gap? Okay, what happens? So if I have a gap and I know that my delta is 0.01 inches because, okay, because this whole thing is having to stretch down 0.01 inches because this one is stretching down 0.01 inches. Now, instead of having to stretch down, 0.01 inches, we can take off that 32nd of an inch of wiggle room. So when I'm looking at the strain now, it should go down because I have a little bit of play in the system. It's going to be 0.081 inches minus that gap, because we're going to fill in the gap before we start actually stretching, 130 inches. And this time I get a strain of 0.00038269 inches per inch, which gives me 1, 2, 3, 4, 5, 6, 383 micro inch per inch. And just by putting that little bit of a gap in there, okay, just by putting that little bit of a gap to just kind of take into account any types of changes, we can see that we've decreased the strain that we undergo actually in the bar itself.